Okay, this is Module 5, Lesson 3. You can either find this on your online book, or if you go to page 153, you will find it there also. I would like if you would complete this in page 153 as you go along. If you don't have your book with you, you will need to get out a work paper because there's lots of stuff that we need to do in this lesson. So let's get started. This lesson is called Compare Ratio and Rates. So our I can statement is I can compare ratio and rates using a table or a double number line. So here's our first section on stepping out. Amari takes orange juice from a can of frozen concentrate and water. The amounts are shown in the picture. So right here, it's really hard to see. You have to read it. We have in the water, we have 3 cups. In the concentrate, we have 2 cups. So Amari wants to make 4 pictures of orange juice. Complete the table to find out how many cups of water and cups of frozen concentrate she will need. So we set up here for 1 pitcher. She needs 2 cups of concentrate and 3 cups of water. So we're going to say 2 and 3. Now, if we do 2 pitchers, 2 times 2 is 4. So 3 times 2 is 6. Okay, if I want 3 pitchers, I'm going to multiply the top one by 3. 2 times 3 is 6. And 3 times 3 is 9. They already have that one for you. If I want 4 pitchers, I'm going to times the top one by 4. 2 times 4 is 8. And 3 times 4 is 12. Then my last pitcher, 5 pitchers, that means I'm going to multiply the top one by 5. So 2 times 5 is 10. And we're done with that. Okay, let's go down to B. Amari's friend Gabriella also makes orange juice from the same frozen concentrate. Using the table, write a rate to represent Gabriella's recipe. Use the recipe for 1 pitcher to write your rate. So I think we are looking right here. For every 3 cups of concentrate, we're going to use 4 cups of water. So we have 3 over 4. Going to go down one more. C. Whose orange juice has a weaker flavor? Amari's or Gabriella's? Find a ratio in Gabriella's table that has the same first quantity as the ratio in Amari's table. So we have a 3 here. Oh, sorry, concentrate. I'm sorry. We have 6, and down here we're going to have a 6 too. So in row 3, this is for Amari. Amari, in row 3, she uses 6 cups of concentrate. Gabriella, in row 2, uses 6 cups of concentrate. If you go and check up on your table, you'll see that. So in row 2, which is right here, 6 cups of concentrate. In row 3 up here, Amari does 6 cups of concentrate. Let's continue to go down. Amari uses, now we have to see how much water. So Amari's on top. With the 6 cups, she used 9 cups of water. And while we're here, let's do that. The other one used 8 cups. So Amari used 9 cups. Gabriella used 8 cups of water. So who uses more water? That would be Amari. Uses more water than Gabriella. So Amari's orange juice will have a weaker flavor because she used more water. Remember, the more water you put in something, the less of a flavor that you have. It'll be watered down. Okay, we went on to the next page. This is task 2, step it out. In your book, you flipped over to page 154. Mrs. Morales teaches computer programming. Each student writes an average of 9 lines of code per hour. So we're going to complete the double number line to find how many lines of code a student could write in a given number of hours. So a double number line just means that there are 2 number lines together. So in 1 hour, she can do 9 lines of code. In 2 hours, because we go from 1, 2, 3. We're going to multiply 2 times 9, and we get 18. We're going to multiply 4 times 9, and we're going to get 36. So we have 1, 2, 3, 4, 5, and we're going to go 6. And take 6 times 9, and we're going to get 54. Now, we're multiplying by 9, because to get from 1 to 9 here, in our first one, we're multiplying by 9. If I check it, I get that, which is right. Okay, Mrs. Sanchez also teaches computer programming. Each of her students is able to write an average of 4 lines of code every 20 minutes. How many lines of code can one student from Ms. Sanchez's class write in 1 hour? So I know what hours they have are written as fractions, but remember when we have the same number as on top, the numerator and the denominator are the same, that's 1. So in 1 hour, it can do 12 lines of code. And that's what they're telling you right there. Letter C. 2 ratios can be compared if both have the same amount of one of the 2 quantities being compared. Which class writes code faster? So, what I need to do, first I need to bring up a work page. There it is. Let me get that pulled up. I'm probably going to have to clear it off from what I did yesterday. Yep. Okay, so the class that can write code, so we need to figure out which class can write code faster. I know, Miss Sanchez, so I'm going to label this one with an S. Sanchez's class, so S class. We said in 1 hour they can do 12 lines of code. So 12 lines over 1 hour. And Morales, I'm going to do M class. We said if we look up here, they can do 9 lines of code in 1 hour. So the people that can do code quicker is Miss Sanchez's class, because they can do 12 lines in an hour. Because 12 lines per hour is faster than 9 lines per hour. Why did I click Morelli's class? I'm sorry. That was silly. Yeah, I even said Sanchez's. Sanchez's class can do it in 12 lines, and the other class can only do 9 lines. Oh my goodness, I am not typing the right things. This is 12. This is 9. This is Sanchez's. There we go. I'm sorry about that. And that's all there is for this first video.